video is about inequalities in one triangle. And in my opinion, this lesson is on the easier side of things, so hopefully you feel the same. So you guys did the Desmos that kind of helped you discover what's going on here, but now we are doing our formal notes. So the first thing is that the longest side in a triangle is going to be opposite the largest angle, and the shortest side is going to be opposite the smallest angle. Okay, so we have 11, 8, and 5 as our sides. 5 is the smallest side. That's going to be opposite angle X. Okay, so we go across the triangle to say what's opposite. So angle X is going to be our smallest angle. 8's the next biggest. That is across from angle Y. Okay, so that is going to be the next largest. And then finally, 11 is our biggest side that is across from angle Z. So angle Z is going to be our largest angle. Okay, hopefully that one's not that bad. The next one is the triangle inequality theorem, which states that the sum of the lengths of any two sides is greater than the length of the third side. So in that triangle that we already had above, 5 plus 8 is 13. That's greater than the other side, which was 11. 5 plus 11 is 16. That's greater than 8. And 8 plus 11 is 19. That's greater than that third side, which is 5. So the sum of the lengths of any two sides is greater than the length of the third side. Okay, those are our theorems. So let's show how we are going to use them. In our first example here, we have a triangle and it gives us 3 sides and it says which angle is the smallest and which one is the largest. So to do that, we are going to look at the sides first and determine how those are being ordered here. So we have 33, 39, and 37. So 33 is the smallest side. 39 is the largest side. And now we have to look at what angles are opposite them. So the 33 is opposite angle H. So angle H is going to be the smallest side. And the 39 centimeters side FH, that's across from angle G. So therefore angle G is going to be the largest angle. Okay, the next one is going backwards. Here we're given some angles. We're going to decide what sides are the longest and the shortest. However, we don't have enough information yet, but luckily we could fix that because we know that the angles in a triangle add to 180. So far we have 66 and 60, which is 126, and 180 minus 126 is 54. So that missing angle O is 54. And now we can compare the 3 angles and see what they're opposite of. 54 is the smallest. Across from it is NP. So this is going to be our smallest side, which is actually the second of the 2 questions. So I will stay down there that side NP is the shortest. And 66 is our largest angle, is across from OP, which means this is going to be the largest side. And that is going to be side OP. Okay, and now for a couple triangle inequality theorems. Here, once again, the sum of any 2 sides is greater than the third. That's what it says. But luckily, the shortcut is you only have to see if the 2 shorter sides add to something bigger than the third. You don't have to sit there and work with every single pair. Okay, so really just add the 2 shorter ones and make sure it's longer than the third one. So we have 2 sets here. In the first set, 19 and 18 are our shortest sides, and they add to 37. But 37 is not greater than 40. So set 1 is a no. Those would not be able to form a triangle. Okay, for set 2, we have 33 and 37 as our shortest. That adds to 70. Okay, 70 is greater than 66, so that is a yes. Okay, I do want to just go back and explain kind of why the triangle inequality theorem is a certain way. I meant to do that earlier. So essentially, if you are trying to get from point X to point Y, okay, the shortest distance between any 2 points is a straight line. So if I go straight from X to Y, that has to be shorter than if I took the detour and took that route to go to X to Z to Y. That's what's going on here. Okay, so that's why a side is always going to be greater than the sum of, sorry, less than the sum of the other two sides. I said it backwards there. Okay. Okay, and the last one. A triangle has sides that measure 11 centimeters and 16 centimeters. What are the possible lengths of the third side? So there's gonna be a range of things. And what is happening here is there's two scenarios. 16 that we're given, that could be the biggest side, which means there's some other smaller one along with the 11. Okay. Um, or the two sides we are given, the 11 and the 16, those are actually the smaller sides, and there's a bigger third side that we don't know. Okay. The 11 is never going to be the biggest side because clearly 11 is not bigger than 16 anyway. So it's either 16 is the biggest one, or there is another bigger one that we don't know, and these two are the smaller ones. Okay. Now, if 16 is the biggest, okay, that means that the other two, 11 and the one we don't know, have to be bigger than 16. Okay. So hopefully we are realizing that that is going to be like 5. 5 is the cutoff. It can't be 5 because 5 was 11 and 16 and it needs to be bigger than 16. Okay. We're actually going to write this as a compound inequality, specifically an and compound inequality, because those are the inequalities that give us a range from a smaller number to a bigger number, so we can include everything in between, fractions, decimals, you name it. Okay, so here, 5 is the smallest it can be, but actually can't be it. So we're going to say 5 is less than x, which if I read it backwards, essentially means x is greater than 5. Okay, it's got to be 5 or more. It can be 5.0001. That would work. Okay, so 5 is less than x, aka x is greater than 5. And on the other end of things, if these two are the smaller ones, okay, it's got to be less than 27. Okay, if our third side was bigger than 27, then that would mean that 11 and 16 would not add to something bigger than the third side. So this is how we are going to write it. This is an and compound inequality, in case you don't remember those from algebra, which essentially state what the min and the max are. And to get these numbers, if you did not realize that you subtracted them to get this, 16 minus 11 was 5. And on the upper end of things, you would add them. Okay. We don't just want to list like 6, 7, 8, 9, and so forth. We don't want to just list numbers because, like I said, it could be fractions, it could be decimals. And we want to show it could be anything in that range between 5 and 27, just not those numbers themselves. Okay, so those are inequalities in one triangle. We will have also inequalities in two triangles, but that will be our next lesson.